Bismillah ar-Rahman ar-Rahim, my dear students at Ajman University. Today we will continue part C of chapter 5, and that is regarding controlled clinical trial evaluation. So what we are going, or how we are going to do the evaluation of a clinical trial that has been published. If you remember, in last part we talked about randomization, number of recruited subjects, blinding. Today we will continue. Usually in the last part of the methods, okay, that's what you will see in the manuscript. Usually in the last part they will talk about statistical analysis. And in statistical analysis, they need to talk about how they are going to evaluate the data they get from the experiment they had. Usually, especially for large clinical trials, usually they need to have a biostatistician who will be one of the investigators of the clinical trial. Now, you remember, we said that some of the clinical trials involve hypotheses, and that is null hypothesis and the alternative hypothesis, or what we call research hypothesis. So we will focus on clinical trials involving these hypotheses. But I want you to remember that even when a biostatistician is involved, that does not mean that you will accept the result as it is, because it can have some bias. So let me go back to the hypothesis. Before we talk about the analysis and what type of analysis we use, you need to be familiar with the type of data that you will collect from the clinical trial. Now, there are 4 types of data that you need to be familiar with, and these are the nominal, okay, nominal data, and ordinal data, interval, and ratio. These are the 4 different types of data that you will collect. Now, let us talk about each one. What do we mean by nominal? Nominal refers to a categorial response or categorial result. For example, let's say I want to see if there is angina pectoris, or there is myocardial infarction, or there is a stroke. So the answer is like yes or no. So it's categories. Category for yes, category for no, or category for angina pectoris, category for myocardial infarction, category for stroke. So this type of data is different, for example, compared to ordinal data. Ordinal data, although there can be categories, okay, but the categories that are there are related to each other in a ranking way, okay? Like, for example, I will not rank myocardial infarction by number or by a certain type of ranking, and angina pectoris another rank, and stroke is another rank. No, these are different things. Like when, for example, I talk about colors, yellow, white, brown, things like that. So in ordinal, no, there is a type of ranking. And let me show you an example of that, okay, so you can understand what I mean by that. For example, Likert scale is a 5 category or 5 scale that are there. And this is actually what you do when you do the evaluation of courses and evaluation of other things. See, you rank it from 1 strongly disagree to strongly agree number 5. So there is a kind of ranking, صح? But the distance between 1 and 2 is not necessarily the same as the distance between 2, 3, 3, 4, 4, 5. Similar thing when I talk about another type of ranking, as you see here, or maybe something like here, extremely unimportant, very unimportant, unimportant, etc. If you also have a pain scale, okay, and it can be analog or visual, as you see here, there is a kind of ranking between them, okay. So mild, no pain comes here, for example, 0, while mild pain will come next to it, and then moderate pain more, and then severe pain, okay. At the end you have worst pain ever. Now this is a ranking, okay, so there is a kind of order between them. This is unlike when I talk about colors, or when I talk about a kind of category with no ranking between them. So when I say ordinal data, they are categorial data, but there is a kind of intrinsic order between them, okay, such as I told you, pain, severity. Now when we go to the other ones, interval and ratio, they are usually both together referred to as continuous type of data. Continuous type of data, like for example age, blood pressure, cholesterol. When I say gender, female or male, what type of data is this? We call it nominal. We don't call it ordinal. Okay, when I say blood pressure or temperature, this is a continuous type of data. The difference between interval and ratio is that in ratio you have absolute zero, real zero, okay? While in interval there is no absolute zero. I'll give you an example. When I say there is zero cholesterol, it means there is really nothing, no cholesterol, صح ولا لا? So it's real zero. And in this case we will consider it as ratio. But when I say 0 degrees Celsius, which is the temperature of the water when it gets solidified, that's not real zero. It's for water, okay? Now for other materials, it will not be 0, the freezing point. It will be something else. So it's not real 0. So when we talk about ratio, we are talking about, for example, cholesterol, blood pressure, where 0 means 0, okay? While interval, they don't have a real 0, okay? But as I told you, we deal with them in the same way. Now, depending on that, we will carry out the analysis. But here in this table, you will see a summary of the data, nominal, what type of data it is. It's categorial, such as yes, no, alive, dead, colors, okay. Data placed in one category, but it cannot be more than one category, okay. يعني mutually exclusive. It cannot be in more than one category, just one category, yes or no, okay. Ordinal اللي هو categorial data, we consider it as categorial like the first one, but there is, as I told you, there is intrinsic order in them. We use, for example, visual analog scale, such as what you saw here. This is visual, okay, analog scale. Okay, so according to the face, you can pick one. Likert scale is an example of ranking or ordinal type of data. Interval, such as temperature in Celsius or Fahrenheit, okay, and these data have, there is equal distances between the points. يعني between 1 and 2 is equal to between 2 and 3, 4 and 5. بالordinal it's not necessarily that. Even though, let me go back here, even though we put these numbers, but you know, you cannot ask one, why did you say it's 1, not 2? Maybe it's 1.5. So what is 1.5? Is there a real precise measurement between 1 and 1.5? Will you consider it as 2 or 1? يعني there is no equal distances, even though there is ranking, but there are no equal distances. Okay, even though we try to put them here as equal, the distance between them may not be necessarily equal. With dalil, okay, the evidence for that, maybe the same person is saying today for the pain he's suffering that it's mild, and tomorrow, even though he has the same pain, he might consider it as moderate. Okay, فإذا حتى هون الجudgment is in the يعني comes with unequal يعني response. Okay, it will come with unequal response. That's why many of the questionnaires that involve this scale, we cannot consider them to have equal distances. So we need to maybe analyze them using a different way. طيب, بالinterval distances are equal, but there is no absolute zero. The ratio is the same thing. There is equal distances between the points, but there is a real zero, such as when I say the temperature, but in Kelvin. إذا بتتذكروا it's minus 273 maybe, or something like that. Okay, that's طبعا that's the 0 Kelvin, اللي هو equal to minus 273 maybe, or 71 degrees Celsius. هذاك هو 0 لكلفن, which is real zero. Blood pressure, cholesterol level, white blood counts, هدول, all of them we consider them as ratio. Usually we use similar data for nominal and ordinal, similar type of analysis for ordinal and nominal, and similar type of analysis for interval and ratio. طيب, when we want to do the statistical analysis, first you need to know what you need to show others. So according to that, there are two types of statistical analysis that you can do, either inferential statistical analysis or descriptive statistical analysis. So with the data you have, you can do both, or you can do one of them, inferential or descriptive. Usually when you do inferential, you will have also to do some descriptive analysis as well. But if you do descriptive, maybe you don't need to do inferential statistical analysis. So what do we mean by inferential? Inferential, as you see here, the meaning is istidlali. So from the groups that I have tried my medications and my control, from the data that I collect from my groups, I want to infer, or I want to relate that to the population, to the whole population that have similar inclusion and exclusion criteria. Okay, or that they meet the inclusion and exclusion criteria. So when I want to take the information from my sample and relate it to the population, then this is inferential analysis, statistical analysis. But if I want just to describe my groups or my subjects in my study, then I want to describe them, then I will use descriptive methods. So let us talk about description. How can we describe my group? Okay, now I'm talking about descriptive analysis. We can describe them by giving the mode, giving the median, giving the mean, giving the range, giving the interquartile range, and giving the standard deviation. طيب, let me first define each one of these so you understand them. Mode معناتها the most frequently occurring data point. مثلا, if I want to see, for example, let's say in my group I want to see يعني which age أي عمر, which age is more frequently repeated. يعني مثلا maybe 65. Many of the subjects I have, they have the age of 65, and maybe fewer are older and fewer are less than that. So mode reports the most frequently occurring age data point. Median is the midpoint, okay, of the data. يعني there will be 50% of the data lie above it, and 50% of the data lie below that. For example, if I say the median is 65 years, طبعا I'm talking about the age, معناته half of my subjects will have age more than 65 and half of them will have age less than 65. Okay? When I say mean, طبعا we refer to it as average, but the right term to use, the more precise term to use is mean, because average can be also median and mode, okay, even though we refer to it usually for the mean. Is a convention, yes, average is the mean, but as a term it can also mean the mode and the median. And these three are also referred to as measure of central tendency, center of the population. So mean is the average, okay, so you take all your data points and you calculate the average. For example, I may take all of your scores in quiz 4, for example, and then I will add them all together, and then I will divide them by your number, and I will get the average. Range, طبعا this is between the minimum data point and the maximum data point. For example, I can say that in your quiz, the minimum was 3 out of 10, and the maximum was 10. So the range is from 3 to 10. Interquartile is different. It's a range, yes. Okay, so interquartile is a range. Now this range from 25% to 75%. What does it mean? So I will take the number of the data points. For example, let's say your score in the quiz. If I say the interquartile range is from 5 to 8, what does it mean? Is an out of 10. Your scores for the quiz is in the interquartile range is from 5 to 8. What does it mean? 5 means 20% of the marks are less than that, and 8 means 75% of the scores will be less than 8. So here I will say, okay, it's 5 to 8, for example. Okay, what is this 5? معناتها 25% of the marks. يعني maybe let's say 10 of you have got less than 5. Okay, what is 8? 75% of the marks are less than this. يعني maybe let's say 30 of you are less than 8. Okay, what about the other 25? They are more than 8. Okay, range can be, for example, as I told you, from 3 to 10. What is the 3? This is the minimum score. What is 10? This is the maximum score. Remember that all these things are for descriptive analysis. يعني I'm describing my group. While SD refers to standard deviation. And standard deviation is required in order for you to show the reader how versatile or how is the variability in your group. يعني, let's say I said that the mean score was 8, okay? طيب, but I don't know how the variability in the scores. هل هي very variable ولا لا? So I can say, okay, plus minus, or for example, I can use here symbol to add plus minus. Where is it? Plus minus, okay, more simple. Okay, I don't want to waste a lot of time searching for it, but it's there. It should be available. Okay, anyway, it's, I don't want to waste time now. So plus minus, okay, 3. What does it mean? Okay, it has a meaning, or plus minus 2, let's say, or plus minus 1, or this can be 7 or 6. Now, what does it mean? Okay, this number talks about the variability, okay, the differences. Are there a lot of differences between the students, or they are very close to each other? So standard deviation gives you an idea about the variability of the data in your group, okay, in the group that you are describing. So usually we use the mean plus minus the standard deviation. طيب, so when I say plus minus 1, what does it mean? Okay, طيب, we'll talk about this. But first, before we talk about this standard deviation, let's see where we can apply these measures. For nominal data, I only can talk about the mode. For example, if I say dead or alive, this is an example. I cannot say what is the average, صح? What I can say is there are more alive subjects than non-alive. I can put the mode. The highest is the alive people. Or, for example, if you are at the college and you looked at the window and you saw, you see many cars with different colors, then you can put them in a table and say, for example, white color, there are 10 cars. Yellow color, there is 1 car. Red color, there is 3 cars, and so on. And the mode will be the most frequently occurring color. اللي هو مثلا, for example, white. There are 10 cars, so the mode is 10. Okay? But I cannot say the average, because these are different colors, different categories. I cannot take their average. Okay? في الordinal, طبعا, if I can take only the mode, بما إنه I cannot have the mean, then I cannot have also the standard deviation. I cannot have the other things. Okay? If I say ordinal data, well, I can say, for example, most people, okay, let me go here, are having moderate pain, okay, or number 4, or moderate pain. I can do that. Okay? I can also talk about the median. For example, I can say that 50% of people, they have less pain than moderate, and 50% they have more pain than moderate, for example. Okay? But I cannot get the mean, or I should not, to be more accurate, I should not calculate the mean, because mean assumes that the distance between the different categories here are equal, and we do not have something precise to make sure that they are equal. Okay? فإذا I cannot have mean. Because I cannot have mean, I cannot have standard deviation. But I can have range. For example, I can say that people ranged from no pain to worst pain, okay, or from 0 to 10, and 25% to 75% were from 2 to 8, for example, or from mild pain to very severe pain. Okay. بينما الانترفال والريشيو provided they have normal distribution, وانتبهوا, provided they have normal distribution, I can calculate the mode, I can calculate the median, I can calculate the mean, range, interquartile range, and the standard deviation. Okay? That's why I told you in the beginning you need to know what is your data, because your data will dictate what type of analysis you can do and how you should be representing your data. طيب, let me go back to here. When I said 6 plus minus 1, what is this one which is talking about the variability? طيب, in order for me to explain it for you, I want you to look at this distribution of cholesterol level, okay? And it looks like normal distribution. And what type of data is this? It is a continuous type of data. It's ratio, a continuous type of data. I can calculate, as you have seen in the table, for interval and ratio, I can calculate the mode and median and mean, range, interquartile range, standard. I can do all these things. Okay? As I told you, it's very important that your data is normal, and usually, not always, but usually, the continuous data present you with a normal distribution, usually, especially if you are taking a representative sample from the population. The sample is representative. Okay, and how do you get representative sample? That is by randomization and having real or good inclusion and exclusion criteria. طيب, let me go back. So this is the data of one of your groups. This is the data. You will see, because it's perfectly normal distribution, you will see that the mode, median, and mean are the same. إذن بالperfectly normal distribution, mode, median, mean will be the same. بالperfect هذا. Okay? Usually طبعا the subjects in your group will not have a really perfect normal distribution, but even anything close is good enough. You can still apply your data. Okay? طيب, شوفوا here the average or the mean, which is the same as mode and mean. The mean cholesterol level is between 130 to 160. It's 145. Okay, so this is the mean, 145. طيب, when they calculated the standard deviation, they found that it is 15. So they said, okay, I want to describe my group. It has a mean of 145 milligram per deciliter. Deciliter يعني 100 ml. Okay, with a standard deviation of 15. What does it mean, this 15? Okay, which is talking about, don't forget about the variability in your group. Okay, or the diversity. شوفوا, another thing, the diversity in the values. Okay, it means if it is normal distribution, then طبعا assuming normal distribution, then 68 or 69 of the about 68% of the group, 68% of the subjects in your group will be between 145 minus 15 245 plus 15, which means what? Which means 68% of the subjects in your group will be between 130 to 160. Okay? That's why it's based on normal distribution, because this is according to normal distribution. طيب, if I take 2 multiply the standard deviation, يعني plus minus بدل 15 2 into 15 30. Okay, so it's 145 plus minus 30. So here I use 2 multiply for standard deviation. So what does that mean? Because as a reader you should understand what does it mean. Okay? طيب, 145 plus minus 30, it means it's going to be from 115 to a dash 175. What does that mean? It means according to normal distribution, okay, assuming normal distribution, that about 95% of the subjects in your group have this range, or they are lying in this range, mean 115 to 175. طيب, شوفوا, if I take 3 multiply standard deviation, يعني 45, in this case the range will be from 100 to a dash 190, from 100 to 190. This means about 99% of the subjects in your group will lie in this range. So now all of you should be aware of what standard deviation represents. طيب, let me compare this. Okay, please look at the values here. This is the mean, okay, and how the variability or diversity in the data sets. You see here most of them, okay, which is the mode, most of them are 145, and it's equal to median and the mean. طيب, I want you to compare it to here. Look at this one. What you will notice, the also mode, median, mean are the same, which is 145. شوفوا هون, let me go back. 145. But there is something different here. Yes, it's normal distribution, but the variability is less, because most of the data here are diverse. They are little far away from each other. But here, most of them are closer to the average or to the mean value. So the diversity here is less. Okay? So let's assume that the standard deviation here is 5 rather than 15 here. Isn't 15 means there is a lot of variability, for example, compared to 5 here. So if I say, okay, the mean is 145 plus minus 5, طبعا this is the standard deviation, it means 68% of the subjects will be from 140 to 150 milligram. And about 95% of the subjects will be from 135 to 155. And more than 99% will be from 130 to 160. So now you understood, okay, what do we mean by standard deviation and what information it tells us. The lower the standard deviation, the less is the diversity in the values. معناته values are closer to each other. But you should be careful, because some authors, they may report, instead of SD, which is the standard deviation, they will put SEM, which is something related to standard deviation, but it's different. Okay. Now, when you report SEM, it means that you are looking at the population. بدأت الانفرنشال statistics. Okay, so standard error of the mean, yes, it is related to standard deviation, but it's used in inferential statistics, which means I want to look at the population. So how is this calculated? Standard error of the mean. Standard error of the mean is equal to standard deviation divided by the square root of the number of subjects. Okay? Okay. See, I'm not sure if it is here. Okay, so أيوة هي هون. Okay, so it's standard deviation divided by the number of subjects in your group or in the group you are analyzing. That's why SEM is always less than the standard deviation, because the number is usually, you know, 5, 6, 7, 10 and more. Okay, rarely you will see something less than 10, which means if I take 9 for example, so standard deviation divided by square root of 9, which is 3, so you are dividing the standard deviation by 3, which will lower the value that you will get. So SEM is smaller than standard deviation. So sometimes the authors, they would like to put the SEM so that the reader will think, okay, oh, he has in his group or in this group, there is little variability between subjects, because this can have implication for the interpretation of the data. Okay? While SEM means what? See, if طبعا I'm assuming here there is normal distribution and there is a representative group from the population, what does it mean when I put the mean plus minus SEM? Okay? SEM or mean plus minus SEM indicates, وانتبهوا, it measures the deviation of individual sample means. Okay, so here from my sample or from my group, I want to see how it deviates from the population means. قديش بعيد المين تاع الجروب تاعي, okay, which I'm measuring, how far it is from the population mean. Okay, now if you take the mean of your sample plus minus 2 multiply في ال SEM, هي 2 SEM, then what does that mean? What is this range that you will get? It means 95% of the time the true mean of the population lies in that range. طبعا, let me go back here and tell you the following. Now, when you do your clinical trial and you get the results from each of the two groups that you have, one is control, one is the intervention, and from your intervention you want to say, okay, how will it be in the population? Okay, so what you want to do, you want to say, okay, I don't know exactly what is the mean of the population. I only know the mean of my sample. So how you can relate to that, to the true mean of the population? You can use SEM, standard error of the mean. So you want to see how far, okay, you are away from the true mean. How far is your mean from the real thing? How far it is? So what you do, you take the mean of your sample plus minus 2 في ال SEM. If you take 1 في ال SEM, then you are covering only 68% of the possibility, okay, that the real mean of the population is in that range. So you want to cover more. 68 is not really good enough, because there is high possibility that the true mean is not in this range. So if you take 2 في ال SEM, okay, then 95% of the time it is possible that the true mean of the population is in this range. طب هذا الرينج where did you get it from? From your sample, from your group, plus minus SEM. طيب, look back at SEM. شوفوا, which is actually equal to standard deviation by square root of n. شوفوا, if I have very large n, okay, very large, let's say I put here 100,000s, okay, then what is going to happen is that your SEM will be very small and very close to 0. Let's assume it is 0, okay? So SD divided by the square root of very large number, let's assume it is 0. معناته 2 في ال SEM is 0. معناته, which means that the mean of your group is the same as that of the population, okay? And this is what I explained to you when I talked about the number, okay? Let's say I want to take a representative individuals from your class, okay, and then take the mean of their quiz scores, okay. طيب, if this sample that I took from your class, maybe it's 10 students, okay, will be maybe close to the true value. But the more I take, the closer I will be to the true value. So in the end, maybe if one of the students is left, only one is left, I didn't take that student, then that student will not affect a lot the real or the mean that I will get, which is very close to the true mean of the class. Okay, so what does it tell me here? That the higher or the larger the sample number, the closer I am to the true mean. طيب, again, let me ask, why don't I take the whole population and do the clinical trial on the whole population? The reason is, a lot of money, a lot of time, it's not feasible, etc., etc. طيب, usually when they start talking about inferential statistics, they may determine the 95% confidence interval, as you have seen it here, or they may present a p-value. For example, they tell you, okay, in group A with group B, okay, the cholesterol level here was 140, and in the control it was 185 مثلا. Okay, so they will give you these two numbers, and then they will tell you p-value is equal to 0.02 مثلا. Okay, طيب, now once they put this p-value, you should know, what does it mean? Does it mean there is a significant difference between them? Okay, is there a significant difference between the two groups? Now, p-value will allow us to know this, if there is a significant difference. But first, in the methodology, the authors or the investigators, before they start their trial, they should say what is their alpha value. Okay, what is their alpha value? Okay, or how they will say it. They will say it according to the following. They usually use a certain way to say, okay, they will say, for example, alpha, they will say في methodology, before they put the results, okay, they will say that their alpha is equal to 2.05. طبعا هون 0.05, or they will say that significance level was set at 0.05, okay, or something similar. I will show you what is the similar things that they will use. This is in the statistical analysis. Usually the last things fill methods, okay. So what does it mean? Before I talk about this p-value, let me first explain what does that mean, and we will talk more in details later about alpha and beta also. It means I am willing to accept mistakes. I'm willing to accept mistakes if it is less than 0.05, which is 5%. هاي معناها ايش؟ 5%. Okay, when I say that A and B are different, إذا انتبهوا يعني I'm accepting H1 اللي هي alternative or research hypothesis. يعني I'm willing to have probability of mistakes less than 5% if I say that A and B are significantly different. So this is the level that I determined in my statistical analysis. So if I get P equal to 0.02, you will need to compare it to this one. If it is less, then you will say that these two are significantly different. Okay? If it is 0.5 or more, okay, then you cannot say that they are statistically significant. Okay? Is this clear? So if it is equal or more than 0.05, you cannot say because the error here will be high. طبعا هنا alpha, usually they will put it as alpha yes equal to 0.05 أو طبعا هون ممكن يكتبوا is considered significant if p value is equal or less than 0.05. Sorry, less. Usually less. The right thing is to use less, not equal. Okay, so this is the usual way of doing this. So now we know what is alpha. Alpha is determined from the beginning. Okay, it will be in your statistical analysis of the data in the methods. Okay, before you start talking about the results. Okay. طيب, now regarding the tests we do, the statistical tests we do, it depends on whether my data are being parametric or non-parametric. Now there is a difference. When we say parametric, it means it follows a certain distribution. طبعا بين قوسين between brackets normal distribution. So if my data, as I have showed you before, if my data follows a normal distribution, then I will apply parametric tests. And if it is not, then I will apply non-parametric tests. Normally, typically or normally, continuous data, but not always, are assessed via parametric tests, while categorial data اللي هي ordinal will nominal, they are assessed by non-parametric tests. Examples of parametric tests include students t-test, ANOVA or analysis of variance, analysis of covariance. هذول ايش؟ These are examples of tests that are applied for continuous data if they are normally distributed. Non-parametric tests include chi-square They write it as that, chi-square test. And we have also Mann-Whitney test. What I did, if you go to Moodle, you will see that I have added for you some of commonly used tests and when do you use them. Now, this is very beneficial to you, so I want you to look at that. Okay, see here, these are two files, okay, which will be very beneficial to you. So, for example, if I click here, you will see the tests that can be applied, and these are frequently used analytical methods. في عندنا chi-square test, it tells you when do you use it, and we have Mann-Whitney test and when do you use that. Okay, so this is really beneficial, which I advise you to look at. طيب, also you may في statistical analysis under methods في manuscript, you may say that they are talking about unpaired versus paired, or they may say that we have done the analysis using unpaired tests. Okay, so what do we mean by unpaired? طيب, unpaired طبعا it's the opposite of paired. طبعا paired يعني متزاوج. Okay, يعني together. Okay, you remember when we talked about the design of the controlled clinical trial. تتذكروا we talked about parallel design as opposed to crossover. تتذكروا هاي الشغلة؟ Parallel معناته there are two independent different groups and I'm trying something in each group different from the other group. Crossover is I have one group and trying medication A in this group, and after some times I stop that for some time and then I try medication B. So I'm using the same group, نحكي له crossover. If you are using crossover, then you will use paired. يعني when I put the results from medication A and medication B, and I have a subject مثلا سلمى في group A, and I put her result في group A, في group B بنفس opposite or paired to that, I will put her results when she takes medication B. I can't just put them randomly, so I have to put it لما أسوي pairing. The result of Salma في drug A, the result of Salma في drug B. Then the result of Samer في drug A, the result of Samer في drug B. Then the results of Sarah في drug A, the results of Sarah في drug B. The results of Sally في drug A, the results of Sally في drug B. The results of Jude في drug A, the results of Jude في drug B. Okay, so they are paired. Okay, so but if I do two different groups, then I will use unpaired analysis. So now you should understand when unpaired and paired are used. Okay, this is the type of analysis. And by the way, the nice thing في Excel, which is very simple one, طبعا more complicated, you can go to SPSS for example. And there are some statistical packages, some statistical software that are also available for free. But if I go to data here and data analysis, okay, you will see here some of the tests like ANOVA. Okay, you will see descriptive statistics that can help you. And what else? Okay, شوفوا هون, you will see here t-test, paired two samples for means. Okay, paired. Then I have to use paired only when I'm doing crossover design. Okay, is that clear? So paired is used when I do crossover design. But you may also hear about one-tailed or two-tailed statistical analysis. Okay. طبعا two-tailed statistical analysis is more common. Okay. You remember here when I talked about p-value, okay, which is if it is less than 0.05. You remember here when I talked about 95%. طيب, when I talked here 95%, معناته في 5% احتمالية, possibility 5% that the true mean is not in the range اللي هو mean plus minus 2 SEM. في عنا 5%. طيب, this 5% it means في احتمالية 2.5% to be more above the range وعنا 2.5% to be below the range. Okay, in this case, this is two-tailed test. نعتبره two-tailed because I'm allowing the true mean to be above or below that. فعندي 2.5% possibility that it will be above the range and 2.5% possibility to be below the range. This is the most common way. And when the investigator does not know whether the real thing will be more or less, then he will use two-tailed. But when the investigator knows for sure that it can only be more, not less, it cannot be, for example, if I'm comparing cholesterol drug with placebo, I know my cholesterol drug is going to improve cholesterol level, okay, by reducing it. Okay, I know that. So the population cannot be less, it can be only more. Okay, in this case, they may use one tail. If they use one tail, it means the 5% here possibility will be above only in one direction. So what is two-tailed? Two-tailed, also known as two-sided, are used for trials in which the investigators are not sure in which direction the primary endpoint will be affected by the intervention. Okay? Two-tailed are more common. Type one-tailed test is primarily used in a study in which the direction of the effect of the intervention and active control are known. So they are known to have only positive direction. Okay? طيب, this is regarding one tail, two tails, paired, unpaired, and probability that they may use it, or p-value that they may use it to judge whether two readings are different from each other. Now, let's go back to type 1 error and type 2 errors and power analysis. طيب, to summarize that, these errors are related to errors that we make in judgment. لما نسوي judgment and say, okay, these are different or these are not different, not significantly different. Okay? Now, we have the null hypothesis, which means there is no significant difference, and we have the research or alternative hypothesis, which means there is a difference. So according to p-value, as I have explained previously, okay, if I go back here, according to p-value and what is my alpha, then I can judge and say whether it's significantly different or not. Okay? طيب, whether I say there is no significant difference or I say there is significant difference, you must know that there is a possibility of errors. Why? من وين جاي الerrors? Because I'm talking about my sample. I'm not talking about the whole population. The whole population will give me the true value. My sample will give me something representative, but there can be error. لأنه maybe my sample is not representing the population. Okay? طيب. When I say there is significant difference because my p-value is less than 0.05. Okay, so I decided, okay, there is significant difference. Then there may be a type 1 error. And what I got, we call it false positive finding. And we try to control it by alpha. Alpha is controlling this error, the alpha that I put and I choose. And if you remember, usually, but not always, it's limited or it's set to 0.05. Okay? Or 95% when I talk about confidence interval. Okay? And if there is error in my finding, we call it false positive finding. طيب. If I did not find significant difference, okay, معناته I may be committing type 2 error. And type 2 error is called false negative finding. يعني I did not find a difference between the two groups when in reality there is a difference between the two groups. Is this clear? طيب خلونا نشوف هدول التو type of error. Type 1 error, we use it or we control it by alpha, and usually alpha is set to 5% because we don't want this error to exceed 5%. Okay? And it happens when we say that there is a difference, but in reality or actually there is no significant difference. الحقيقي. طب ليش why I'm talking here about true and not true? Because as I told you, I'm not testing the whole population, I'm testing sample of that. Okay? So I don't know what is the true thing really, for sure, 100%. I don't know. Okay? طيب. Is an alpha is used to control this error, usually set to 5%. Some investigators, they want to be more strict, so they may set alpha تخيلوا to 0.01, they will say, not 0.05. And some, they may say, okay, we want to put it as 0.1, which is, to be honest, very non-strict and very flexible, okay? So this is usually not accepted. The most commonly used is 0.05. And if they use 0.01, they are more strict. But the problem is, okay, if they do that, okay, and they did not find a significant difference, it will be possible that there is a significant difference, but they were not able to find it because of their very strict measure for alpha. Okay, so if they say, okay, 0.01, and then when they looked at the results, they got a p-value of 0.02. Okay, normally this should be significant, but because they put their alpha as 0.01, they were not able to say no significant difference. Okay, طيب, while in reality there is a significant difference. That's why 0.05 is the most commonly used one. Okay, but the good thing, if they put 0.01, sorry, and then they got like something like that, then what does it mean? It means even though they have used very strict alpha, there was very clear difference between the two groups. There is a possible, شو يعني p-value here? 0.001, 1 in 1,000. There is a possibility of error on 1 in 1,000. تخيلوا, okay, there is no significant difference between the two groups. طيب, type 2 error is controlled by beta, and beta is accepted to be a maximum of 0.2. تخيلوا. But we don't really consider beta a lot, except for the study power. Its importance is in the study power. Okay, that's why beta is important. But what you will see, 0.2 20% error. يعني we are accepting 20% error, up to 20%, which is a lot. صح ولا لا؟ طيب ليش هنا we are accepting 0.05 error, but here we are accepting a larger error? Okay, I will talk about that. But first of all, if this error happens, يعني let's say I got 0.001 and let's say it was an error, يعني there is a possibility of error. I told you there is always a possibility of error because your sample is not the same as the true mean of the population. So there is, حتى لو if it is small, but there is a possibility. So what can cause this error? That's what you need to know. Now, when you say there is a significant difference and in reality it's an error, okay, then this error was because of chance. يعني it was because your sample was not the right one. يعني you picked by chance a wrong sample, subhanallah. Okay? While for type 2 error, اللي هي you are saying there is no significant difference, اللي هو false negative, okay? There is no significant difference, but in reality there is a significant difference. So what can cause that error? A chance is one, yes, but also the sample size is this type of error can be eliminated by increasing the sample size. Okay? طيب, let's go back now. Why we are willing to accept less error when we say there is significant difference than when we say there is no significant difference? The reason is because when we say there is a significant difference, it means most probably the drug will be used in the market. For example, I'm comparing my drug with placebo. My drug is better and it is safe. So let me use it in the market. I will get approval and it will be used in the market. And this can this can cause unnecessary harm to people. Okay? So I want to control that. But if I say, okay, there is no difference between my drug and the placebo, or my drug is not better than the other company's drug, then the physicians will not have to prescribe my medication. صح ولا لا? They don't have to prescribe my medication because it's not better. If it is better, they'll prescribe it. So I'm willing, because of risk and safety, I'm willing to commit type 2 error more than type 1 error, although I want to control both. يعني I don't want to have both errors. Yes, but for type 1 error, it's more important to me than type 2. Remember when I told you about setting alpha value? شوفوا, they may write it in the manuscript as setting the statistical significance to 0.05. or significance level of 0.05, or setting the alpha rate at 0.05. So these are the different things. Or another phrase, if p values less than 0.05, they are statistically significant. The p value, انتبهوا, is not alpha. Alpha is what you set. The p-value comes from the results. Okay, you get the p-value from the results. Then you compare it to alpha. Okay? Okay, now let's talk about power. مثلا, sometimes they call it power or power of the study or power analysis. Now, what do we mean by that? Define it. It's the ability to detect a difference in the outcome between the two groups if it exists. قديش هاي الستادي عندها power to detect the difference if it exists. The minimum that is accepted is 80% or 0.8. So it should be at least 0.8 or 80%. This is acceptable. Okay, so the study should have a power to detect a difference if it really exists by 80%. Now, how do we calculate the study power? It's equal to 1 minus beta. You remember when we said that beta is accepted if it is ish. Beta is accepted to be a maximum of 0.2. شوفوا, it would give you 0.8. طيب, if beta is less, how can you make beta less? Do you remember? Let's go back. Okay, here, sample size. Okay, so you can make beta less if you increase the sample size. وين راحت؟ Okay, so if it is here, if we decrease beta, then we will have a higher power. Okay, so the larger the sample size, the higher is the power of the study. But the problem is, you cannot just go and increase, because it means you will have more and more subjects, and it means this will cost you more money, more stuff to monitor and to administer the drug to the patients, and more patients will be subjected to the intervention and control treatments. So you don't want to increase it a lot. Okay, also if you increase the sample size, it means that you will be able to detect the difference even when it is small and not important. لا, and I don't want to do that. Okay, I want only to detect the difference. أيوه, شوفوا, difference in effect that is important. هاي delta. Okay, so another thing that comes into the calculation is delta. What is the difference that I consider it as important to me? And where do I get this difference that is considered as important? Because I need to use it when I calculate my sample size. Where do I get it? I can get it from prior preliminary research results, or if it is a consensus among researchers. Okay? That's why I have to take appropriate sample size, and this is very important, I have to account for subject attrition. This is very important. Subject and attrition, and those who are not complying with therapy, I may subject relocating, for example, they are going to another place, so I cannot include their data in my study, or maybe they withdraw. They accepted, and after 2 days they said, okay, we decided not to continue with the study, etc. So you have to account for that. عشان هيك, for example, let's say you want to do a questionnaire. So you decided that you need to distribute your questionnaire to 400 subjects, okay, to answer it, because the 400 subjects will give you at least 80% مثلا study power. So are you going really to distribute only 400? What happens if one or some of the subjects, they decided not to respond? Some of them did not complete, they wrote little bit and they did not complete the questionnaire. So you need to account for those missing or not responding or not willing. So instead of 400, maybe you want to contact 800. Okay? So you make into account that you need something extra or some extra subjects, because you expect, طبعا, how do you expect from your experience, from other research, that not all subjects will respond or will continue, for example, in our case here, with the trial. Okay. طيب في results. طب before I talk about results, let me show you this nice piece of work. It's about evolocumab, okay, and this is used to lower cholesterol level. It's very nice, and you will see that it has been published in very well-known journal اللي هو Lancet. Okay, if you remember, when we do evaluation, we have to evaluate the journal, the impact factor, etc. So you need to look at that. If I put here the Lancet impact factor, you will see, طبعا we still don't have for 2020, we have 2019, you will see it has very high impact factor. Even when I go to Scopus and I go to sources, and here I type Lancet. Oh, no. And you look here, the Lancet, it's #1 in general medicine, okay? So it's a very respectable journal, and I expected that it will contain very useful information. You will see here how they do randomization and their procedure, study design, outcomes. Here, see, almost the last thing they will talk about is statistical analysis. Okay, طبعا in this particular study, they talked about the role of funding sources after statistical analysis. Sometimes they put it in the beginning, يعني بعد الdesign, they will say, or included in the design. Okay, sometimes the role of funding source, they sometimes put it in the study design. They talk about that, or sometimes they leave it to the end after statistical analysis to talk about the influence of the company that funded this research. طبعا here they talk about the fundings, but here see the statement which is very important. Even though they received funding from the company that makes the drug, they said the academic investigator vouch for the accuracy and completeness of the data and analysis as presented. Okay, so they have to mention that. So after that, you have the results, and usually in the results, the first thing they will talk about اللي هو baseline characteristics. Okay, so in baseline characteristics they will talk about usually age, sex, and because here they are measuring cholesterol level, they will say what was the cholesterol level at the start of the enrollment, etc., etc., for the different groups. طبعا in this trial they have 4 groups, not 2 groups. Okay, they have 4 groups. عندهم 2 placebo groups وعندهم 2 interventional group. Okay, just for you to know. طبعا there is a reason for that. Okay, so usually they will طبعا in this results you will see usually tables and graphs and figures in order to make it faster for the reader to grasp the information and expedite the understanding of the information. And the first thing they talk about, as I told you, اللي هو baseline characteristics or baseline information. يعني just before they started the trial, what was the characteristics? What was the age? What was the cholesterol level? Were they taking another drug or not? And the importance of this table is for you to see if there are some kind of significant differences between the group. For example, if I go here age, في البلاسيبو 2 weeks group, the age was 51. the first interventional grouب 52.6 طبعا plus minus standard deviation. How did I know؟ شوفوا هون مكتوب data are mean plus minus standard deviation. Placebo, the second placebo group 46.8. And you will need to decide whether you feel that there are significant differences that may influence the results or not. Okay, in some researches they will also have a p-value with each of these in order to let you know if there is any significant difference between the placebo and the intervention. طبعا if they are looking at many things, it is possible that maybe one or two things are significantly different between the placebo and the intervention group, or control and the intervention group. And in this case, you should not just say, oh, it means I cannot depend on the results because there are differences between the two groups. You need actually to see if such things can affect the results of the clinical trial. Okay, so in the beginning, there are demographic factors they will look at, and after that, they should talk about subject dropout and compliance. يعني, did some subjects had to withdraw from the study? And usually they are stated as, انتبهوا, study dropout, or we call them lost to follow-up. And usually they will put them in a table. They will say, okay, there are 5 subjects from group A that were lost because of relocation. There are 10 subjects from group A that they were lost because of kaza kaza. So they need to talk about the major reasons for the discontinuation. Here you need to be careful, because if there is a lot of discontinuation, especially in the intervention group, this can make a question mark. Because you need to think about, what if those subjects that withdrew, they remained in the trial? What would have happened? That's what you should think about. Okay, because such things or such withdrawal can affect the clinical trial. طيب. Okay, some subjects withdrew from the study, but am I going to include their results or the last results I got from them, or I will not include their last results? Now, if I include their last results, we call this type of analysis intention to treat principle. يعني, dropouts are not discarded. Their last data are included in the analysis. Yani, whatever was the last data I got from them, I will include it. Okay? And this mimics what happens in real life, because some people, they may not continue with the medicine, they may not be compliant, they may relocate, etc. But of course, it can be biased, even though I am including them, and this is a good practice. But it can also have some bias. For example, what if the subjects continued? They may have improved, or they gotten worse. Okay, and if they gotten worse, it means still the number that I'm showing with the intention to treat is showing something better than what would have been if all the subject continued. But the worst thing is to use only per protocol. Okay, like for example, or anything that did not complete the trial till the end, I will not include it in the analysis. And my justification is that I only want to see those who have completed my protocol, my procedure from the beginning till the end, because I want to measure precisely the effect of my drugs or my drug and the intervention and the control group. So I will only include those who completed till the end. So I have to be careful and scrutinize more with per protocol analysis method or procedure. Okay? Even though both ITT and PP should be evaluated well, but PP should be evaluated more. Okay? طيب, endpoints and safety. Of course, the most important things, and this should be your focus, is the primary endpoint results. And usually they are presented along with p-values. And as I told you, p-values will determine if there are significant differences between the two groups or not. But secondary results, secondary endpoints, if you remember when we talked about it, can also be presented, and they will be presented in a similar fashion, similar way to that of primary. يعني, I may put the 95% confidence interval, or I may use the p-value, etc. Okay? But you should be careful that even though secondary endpoints can be informative, that they may not be adequately powered. يعني the sample size to measure the secondary endpoint might not be enough. Because remember, when we talked about the sample size, we said that it will depend on the primary endpoint, my objective. So any other endpoints might not be adequately powered. And these include the safety measures. You know, the side effects. Some side effects are very rare or they take long time to develop. So this can be a problem. Another thing which you need to look at, whether the medication titration is allowed in the methods or not. يعني, for example, I might say, okay, drug زي ancillary therapy, if you remember. I may say, okay, take drug A, but if drug A is not enough, I want you to take another drug in order for you to reach a certain value. Okay? So you might be increasing the dose of drug A, for example, from 25 to 50 milligram, and then if it doesn't work, you go for a second drug in order to reach a certain, for example, blood pressure value or cholesterol level. Is that there or not? Because they can interfere with the number and severity of the side effects. So you need to know that safety assessment and tolerability, they may not be strong enough because they may not be powered enough. So the frequency and severity are not accurately measured. Okay, so you need to look at clinical trial duration, sample size, maybe some subjects were excluded from the trial, etc. Okay, I hope this is clear. طبعا again, the dose titration, هل subjects did they take مثلا the maximum dose or below the maximum, in order for you to assess correctly the safety and tolerability of the medication. طيب, surrogate endpoints. You might have heard about surrogate mother, يعني الأم البديلة. Now, surrogate endpoints here refers to a measure of efficacy, يعني something to measure the effectiveness of the drug, which can be a laboratory values or symptoms زي الpain, okay, or a clinical parameter like blood pressure. that are used to substitute the most important thing of medication اللي هو clinical endpoint. And clinical endpoint is related to morbidity يعني diseases and mortality death. شو يعني الموربيديتي؟ طاب ولا ما طاب؟ هل this person cured or not cured? Okay, was he relieved from angina pectoris or not? Did this medication prevented his death or not? Okay. And the most important is the clinical endpoint. This one we can use it to justify changing therapy. Okay. But what about surrogate? Surrogate البديل. Okay. The problem with clinical endpoints is that it takes longer time, much longer time to determine and more subjects. It's costly. So some cases, what we do is we go for surrogate endpoints because there is, and this is very important, there is a clear direct relationship between the surrogate endpoint and the clinical endpoint. Okay? إذا في عندي إثبات. For example, if I reduce blood cholesterol level, this will reduce mortality resulting from cardiovascular problems. For example, if I have evidence, good evidence of such correlation, then I can use a surrogate endpoint. Okay? Low in this case, the cholesterol level. So there must be a good correlation, and this surrogate endpoint is easy, accurately, quickly measured, and at lower cost. So because it's at lower cost, okay, and because it can be quickly and accurately measured, and because it has relation with the clinical endpoints, I might or it might be accepted to use surrogate endpoint. But if I proved that the interventional drug, or the drug that I tested, if I prove that it will improve the surrogate point, there is improvement, then this can be a rationale for a larger clinical trial with clinical endpoints. Okay, إذن just the surrogate will not be enough to change medication that I normally give to my patient, unless there is a proof from a larger clinical trial that also the clinical endpoints will change, will improve. Okay. طيب, what you need to know that, and this is very important, sometimes, and this is the case with Women Health Initiative, although شوفوا low density lipoprotein, total cholesterol, etc., all reduced, but what happens to the cardiovascular diseases? They increased. Cardiovascular events increased even though there is a reduction in total lipids and cholesterol level, but okay, the CV events have increased. That's what we call a limitation of using surrogate endpoint. That's why we, after surrogate endpoint and we have the proof, we have to do a larger trial with clinical endpoint. طيب, sometimes the investigators will do what we call subgroup analysis. Rather than analyzing the whole group A with whole group B, for example, they may say, okay, let's analyze in group A those who are above 65 and those in group B above 65 and compare them. Maybe with age it's different. Or let's compare the cholesterol level for group A with those having diabetes كمان. And the same thing in group B. Maybe those having diabetes, they respond better. Okay, so they will not actually compare the whole two groups. They will go for subgroup analysis. And here we have a problem. The main problem is that, yes, it's like secondary endpoints. They give you additional information. It can be rationale for a bigger trial. Yes, كله هذا good information. But the main thing, first you should focus that this is well-designed clinical trial, and they have mentioned about the subgroup analysis in their methods from the beginning. It did not appear later. Okay, because I will tell you what is the thing that happens. Sometimes when the investigators, they don't find a difference between group A and group B, they start looking for subgroup analysis. Perhaps they can find something with significant difference. Because remember that we can prove differences. We cannot prove similarity, equality. We can prove differences. That's why they want to prove something. So they start looking at subgroup analysis and then presenting something they find with significant difference. That's why it should be already plan. Let me show you here this clinical trial. I will go to a discussion. I'll go to discussion, and discussion I will go to the end where they normally write about limitation. Okay, see, our study has several limitations. شوفوا هون انتبهوا شوفوا subgroup. The analysis of the response based on genotype was post hoc. Post hoc يعني they did it after they already done their experiment. They started to look at genotype. Okay, but of course they explained طبعا any limitation they have to respond. Then why did they يعني okay, then why this is useful if you done it post hoc? Okay, they will tell you that in the study protocol, and should therefore be viewed as hypothesis generating. يعني he say, okay, I don't want to claim that this is accurate, but it can be used in the future if they want to do genotype analysis. Okay. طيب. Also very important thing that when you do subgroup analysis, of course you are using smaller number than when you do the whole group analysis. So what happens to the power? It gets reduced. Okay. Also it's preferable to be analyzed using ITT, especially when you do subgroup, لأنه you have a problem that the withdrawal in one group, in one subgroup, might be more than the other one. So you need to do ITT analysis rather than PP per protocol analysis. As I told you, subgroup analysis can be justification to conduct a clinical trial on such people characteristics. يعني زي characteristic تاعون السبجروب. طبعا if you find that there is a significant difference, you should not overinterpret subgroup analysis or secondary command in the same way, secondary endpoint, and your focus should be the primary endpoint. طيب, ancillary versus adjunctive. You know what happens when they want to test a therapy, okay, for cholesterol levels. You know that food can affect cholesterol, صح? Maybe some people they are eating more fats than others, etc. So they usually طبعا when they want to try cholesterol drug, they usually like to include diet, okay, or a certain food for the subjects, okay, in group A and group B, okay, in order for them to unify, يكون both the food in two groups are the same. فبالتالي any difference will be because of the drug used in group A and that used in group B. Okay? So even though that the diet also contribute to the lowering cholesterol if they use the right diet, okay, but the good thing is that both groups are using this diet in the same way. That's why any differences, as I said, will be because of the drug. But when I say this is, we call it adjunctive therapy. Is an adjunctive therapy is distributed equally among the two groups. So هذا الدايت كان عبارة عن adjunctive therapy. بينما ancillary therapy is different. Ancillary therapy is, for example, let me say, I want to compare okay, let me give you the example of this one. Okay, yes, this one. Okay, I want to compare between esomeprazole, which is a proton pump inhibitor, with lansoprazole من نفس الكلاس, from the same class. I want to see if they are better in relieving heartburn. So I gave one group esomeprazole, the other group I gave them lansoprazole, and I told each group if after taking this medication that you are taking, if you don't feel, you still feel heartburn, you can take antacid as you like. Okay? Antacid as you like. So it depends on each individual. And then see the conclusion. They said, okay, our conclusion is esomeprazole relieved heartburn symptoms better than lansoprazole. But did they mention anything about antacids? Maybe the group taking esomeprazole, they took more antacid than lansoprazole. Maybe they took 8.2 tablets compared to 1.2 tablets, مثلا. Okay, so it's not equally distributed, and the authors would need to discuss this. Okay, they cannot just conclude that one is better than the other without talking about the ancillary therapy. So ancillary therapy is not distributed equally in the two groups. I hope this was clear to you. Inshallah, next time we will finish the last part in controlled clinical trial evaluation. If you have any question, you can ask me in the WhatsApp group, email, or during the lectures. You are most welcome. Have a nice day and goodbye.